So there's the wire loop that's pictured here. That's the component of a machine. And we're given a big hint. We're told that these fit perfectly into a cylindrical container that have, so it's going to look like this, except it's the actual container. And they have the capacity of 32 pi. Remember that the volume, the capacity of a cylinder, is pi times the radius squared times the height of the cylinder. So we're trying to figure out what the wire used to create the loop. So this is the volume. Here, we're going to be using the height of the cylinder for this one stretch of wire. And for the round part here, that's the circumference of the circle, not the area of the circle. So we can't just use pi r squared. The circumference of the circle is 2 pi r. So we can tell, so the length of the wire is going to be 2 pi r plus h. And we have the value for pi r squared plus h. So clearly, we are going to need both r and h to solve the question. Let's take a look at the statements. Statement 1 tells us that the height of each container is 8 inches. So this tells us h equals 8. And therefore, pi r squared times 8 equaled that 32 pi. Divide both sides by 8 pi, and we get, r squared equals 4. So r equals 2, and there we have an r and an h, and we could multiply that out and figure out what that is. This one's sufficient, and we can get rid of b, c, and e. Statement 2, on the other hand, tells us that the diameter of the loop is 4 inches. Remember, the diameter is twice the radius, so this one is ultimately just telling us that r equals 2, and we basically can do the same thing that we did on the previous equation, except here we would plug in 2 for r and solve for h, which would come out to be h equals 8 again. So the two statements individually are each sufficient for us to figure out whatever this is. We don't want to figure out what it is, we just need to know that we could. Answer choice D.